kind of a destruction test to show our covers on clear timing cover for the Subaru is as strong, if not more, than the OEM covers from Subaru. One of our dealers requested it, so we're gonna do this video. We got some equipment today, so this is a heat gun. It's got a display and an internal sensor. It can go up to 650 degrees. In order to check the sensor is actually okay, we also got an airtime sensor. Now, unfortunately, this sensor can only go up to 200 degrees Celsius. So we're gonna check around 200 degrees if they're the same, and then we're gonna move forward and try to destroy the covers and see at what temperature they're gonna be ruined, damaged, and what kind of damage. So yeah, let's start. So we got the heat gun here, and first of all, you can see we got a sensor. It's pretty hot here in Thailand, 32.4 degrees Celsius, or around 90.1 Fahrenheit. We're working in Celsius today. So just put it down here, and this is our probe. Now we're gonna set this to 150 degrees, and we see it's reading 70. It's the internal sensor now. So it's gonna hit the 150. And when it's gonna hit the 150, we'll see it's saying. So right now it's reading 120. We're around that right now. 120. 130. It's a very fast-acting probe. You literally change the position. After it is going to change over. So right now we're sitting at 150. The probe's showing 147-ish. So that's pretty accurate. Let's say that's about 5%. So that's okay. Now we can close this. We'll close this off for a second. And we're going to move to our actual covers. So we know the sensor inside is to be 5% or less. So we'll put it a bit hotter than we predict it to be. And we'll start with 200 degrees. So 200 degrees Celsius. And let's see if it's going to climb up to 200. This way. So it'll climb up. And just for reference, we put the cup and it's focused the heat to a narrower circle, so it's really going to put a lot of heat on the cover. So we're at 200 right now, and we're going to put on the oil cover for like a few seconds, do what's happening. So it's hot, but nothing much so you can see. I'm trying to put it as close as I can without touching it. So the OEM one is made of foam plastic, which is a thermal plastic. It should be getting to a glass transition around 140, 150 degrees, which means it will be soft and you can actually extract it pretty easily. So nothing happens here. And we're still at 200 degrees. And I see all this again without touching it. And only carbon plastic. It's a bit harder. Also 145, 150 degrees is going to get glass transition. So it'll be soft, but it's not going to melt. So again, nothing that you can see is pretty hot. But nothing that you can see. So let's drop it in. Let's put it at 300. So now this is it's going to climb up. Let's go ahead and put it climb up. Okay, we'll set up 300. So it's getting more shiny a bit. Very, very hot right now. It smells like burnt plastic. Yeah, again, not the significant damage, so we can see it. So what? Nothing much you can see. You have to kind of think, but because this is a clear cover, you can actually see it. Here you cannot see it really. It's a big difference when clear cover and a not clear cover. This is a matte finish. It will be very hard to see something as small as this. But if I put my hand on it, it's really hard. It's flat. So let's put a 300 or 50, 250 degrees. Gonna find up. So at 250 degrees, you can actually see it's bubbling up. Clearly bubbling up, and it's starting to burn completely over here. Here we are, 350. So it got more bubbly a bit because you can actually see it in the inside. Again, this is a clear cover. So they're respectively the same. This is burnt because it's black, so it'll burn and bubble on the surface. While here, the bubbles are pretty much inside. I'm scared to touch it, but yeah, outside it feels smooth, but the bubble will kind of get her inside. Here, you can feel the bubbles on top of the surface. Again, different material, around the same melting temperature, same glass transition temperature. Because it's black and matte finish, it will be like this, and this is clear. Now, let's destruct them. So, let's put it at 500, 600 degrees. Alright. See what happens at 600 degrees. I'm kind of scared because it's going to leave a hole and break all over it. You can see it's lifting out a bit. doing about 600. The whole cover, I will take a bit more time because it doesn't burn on the surface like a normal zero plastic. I'll take a bit more time, a bit harder up here. I eventually, as you can see, so as you can see, it melts. It acts a bit differently. The surface is still kind of shiny and smooth, but inside it's will bubbly all over and it will dent in. Here it actually dented out, and the surface is really rough. Yeah, so that's the test. And as you can see, the OEM one, what can we learn from this is that these are as strong, if not stronger. It has a bit different behavior than the OEM. They both started to burn and get a bit bubbly around 350 degrees. And 600 completely destroyed both of them. But these clearly do their job pretty well as they supposed to, as they were designed to. The material is strong as the original one. This really clear. It's a clear plastic cover, so if your engine bay has an exhaust leak, if the headers leak from the merge collector where all the pipes comes in and there is exhaust gas directly hitting the plastic, it will destroy it. It will destroy the OEM one as well. With the OEM one, you might not see it because it's not clear until you get around it. You might think it's grease or something, but eventually when you take them off, you will realize it's destroyed. Now with the clear cover that we make, you'll be able to see it faster because it's clear, it's an aesthetic part, and if something like this happens, if you have an exhaust leak or your engine bay is really, really hot from some reason, you will see it clearly on this. So it's not the fault of the product. The product is amazing, it did its job, as good as the OEM, if not better. Thank you for watching, see you next time.